Hello students. In this short video, we're going to graph a hyperbola centered at HK. Let's take the first example. Graph the equation, identify the center, vertices, and foci of the hyperbola. First of all, I can locate the center, which is HK. Next, I put that on the graph. I put the coordinates. Now, this hyperbola has the negative for the y term. The x term is positive. So that means this is a horizontal hyperbola. In other words, the transverse axis is horizontal. That first number, that first denominator is always a squared. So I have a squared is 16. That means a is 4. And b squared is 36. That means b is 6. So to find the vertices of the hyperbola, remember this is a horizontal hyperbola. The transverse axis is horizontal, so the hyperbola is going to open left and right. It has two branches. So from the center, I count 4 units to the left, 4 units to the right, and I put the coordinates for the vertices. Next, because the x term is positive and the hyperbola is horizontal, the foci are always on the transverse axis and they're inside the hyperbola. Now, to find the foci, I'm going to use the equation c squared is equal a squared plus b squared. And c, I put c squared 16 plus 36, so c is the square root of 52, which is about 7.2. So from the center, I'm going to count root 52 to the left, root 52 to the right. Root 52 is 7.2, and I put that on the transverse axis. So this here, we call it the transverse axis. It's called the transverse axis. Now we still need to graph the hyperbola. So the transverse axis has the center, the vertices, and the foci. Now, we're going to do the following now to graph the hyperbola. We're going to go from the center, erase this. Now, from the center, I go b units up. B is 6, so I count from the center 6 units up, 6 units down. Now, this here is called, right here, when I counted from the center 6 units up and 6 units down, this is called the conjugate axis. So remember, this is the transverse axis, which is horizontal, and this vertical one is called the conjugate axis. Now, to graph, we're going to draw a box. That box is drawn around these two vertices and the 2 points, the end points of the conjugate axis. Then we draw the diagonals of this rectangle or this box. These diagonals are the asymptotes of the hyperbola. So we have the box, we have the diagonals of this box, which represent the asymptotes of the hyperbola, and then I graph one branch. This is the vertex. One branch here approaches the asymptote, and there's another branch of the hyperbola. Again, this is the vertex, and the other branch also approaches the asymptote. Let's move on to the next example. The same thing, we're going to graph this hyperbola, identify center, vertices, and foci. Now, the center, first of all, before I find the center, this hyperbola has, the x term has the negative sign. So, and the y term is first. That means this hyperbola is vertical. In other words, it's going to open up and down, and the transverse axis is going to be vertical. The conjugate axis is going to be horizontal. So let's be careful here with the vertex, with the center, sorry. This is H here, and this is K, because the two terms are switched here. So HK is 3, 5. So we put the vertex, the center, sorry, not the vertex, the center on the coordinate system. Again, the y term is the positive term, the x term is the negative. That means the vertices, I'm going to go up a units and down a units to find the vertices. Now, what is a? A squared is always the first denominator. So a is 2. So a squared is always the first denominator. And b squared is 25. That means b is 5. So to find the vertices, go 2 units from the center up, 2 units down, and there you have the vertices. Next, to find the foci, you're going to use the equation c squared is equal to a squared plus b squared. Again, the foci are on the transverse axis, which in this case is vertical. So we've find c in the equation. So c is root 29. C is root 29, which is about 5.4. So from the center, you're going to count up. So from the center, which is at 3, 5, you're going to count up root 29 and down root 29. So go up 5.4 from the center. This is the center right here. So you go up 5.4, about 5.4, down 5.4, and you put the coordinates for the foci. Now, to graph the hyperbola, remember, we're gonna draw a box. Before I draw a box, I have the vertices. So this is one vertex. This is one vertex. That's another vertex. They're both on the transverse axis. This is called right here, the transverse axis. I need to find the conjugate axis. So from the center, you count B units. So 1, 2, 3, 4, 5. So I'm going to put this. So B is 5. We put the endpoints for the transverse axis. So this the conjugate. This is here called the conjugate axis. So I have the transverse axis, the conjugate axis. Now we're going to draw the box. Erase my. Now the box goes through the vertices and through the endpoints of the conjugate axis. Then we draw the diagonals of this box. The diagonals of this box represent the asymptotes of the hyperbola. And then we draw one branch through the vertex. The branch approaches the asymptote. And we draw another branch which always approaches the two asymptotes. Let's look at this problem here. Here, they asked us to write the standard form of the hyperbola. we're given the vertices and we're given the foci. When they ask you to find the equation of hyperbola or any other conic section, it's very helpful to have a coordinate system. So it helps me with the orientation, whether it's vertical, whether the conic section is vertical or horizontal. So let's put the vertices, and it's very obvious. Let's put the foci. Or before we put the foci, it's very obvious. The vertices are on a horizontal axis. So, and the center will be halfway. The center is the midpoint between the two vertices. Now here you can count the squares or you can use the midpoint formula. So use the midpoint formula to find the center of the hyperbola. And the center is at 3, -2. Do we have to use the midpoint here? No, because you could have just counted the units, but here you have the coordinates as whole numbers. You have to use the midpoint formula if you have here something like, for example, -2.4 or 6.3 -2.4. So when you have decimals, you have to use the midpoint formula. So I have the center. It's obvious again that the hyperbola is horizontal. The transverse axis is horizontal. So we're going to use this equation where the x term has the positive sign and the y term has the negative sign. Distance from the center to the vertex is a. So a is 3. From the center to the vertex, it's 3. So a squared is 9. A squared will be under the x because the vertices are left and right from the center, and it's obvious that it's a horizontal hyperbola. Now let's put the foci. Foci lie inside the opening of the hyperbola, and they're also on the transverse axis. So we put the foci. Again, the center is the midpoint between the vertices and the foci. The foci are C units. If you count from the center to the focus, we have C is 5, which means C squared is 25. We have the equation C squared is A squared plus B squared. So we can solve for B squared now. So B squared is, if you move A squared to the other side, so if you move this to the other side, you're going to have B squared is equal to C squared minus A squared. So B squared is 16. And you need B squared in the formula. Don't find B, please. Just keep it as B squared. So the equation is going to be x minus 3 squared over 9 minus y plus 2 squared over 16 is equal to 1. Remember, in a hyperbola, this is a minus. In the ellipse, this is a plus. And remember, in the standard form, this needs to be a 1.